Welcome to today's lecture. We will be talking about the fractional excretion of sodium, and we're going to go over how to calculate the fractional excretion of sodium, a very simple way of remembering this formula so that you don't have to remember a lot of different variables when you're practicing or seeing a patient or working on an exam. As you know, the fractional excretion of sodium is commonly used to distinguish between the ATN state and a pre-renal state. And in the ATN state, you have a fractional excretion of sodium that is, that is high, and in the pre-renal state, you have a fractional excretion of sodium that's low. And the reason for this is pretty simple. When you're pre-renal, you don't have a lot of volume, so you're low on volume, and you need to keep all of the volume that you can. For the kidney, the best way to hold on to volume is to hold on to salt. So the kidney retains sodium, and in order to retain sodium, a number of mechanisms are activated. We don't need to go into those mechanisms today, but what we do need to know is that when you retain sodium, your fractional excretion of sodium, which is the amount of sodium that you excrete based on the amount of sodium you filter, goes down. Now we come over here to ATN, for example. ATN is a slightly different situation. The fractional excretion of sodium is high, and that's because the kidney is damaged, so it cannot hold on to sodium. So you have a damaged kidney that cannot hold on to sodium, and therefore your fractional excretion can be any value but not low. And so we usually have a fractional excretion of sodium that is either normal, uh, which is NL, or high. And so this is a very useful formula to figure out whether you've got ATN or pre-renal azotemia. So let's work through the calculations, and that way you'll have an understanding of where the formula comes from and an easier way to remember this formula. So let me draw a line here, and let's start with what the true definition of a fractional excretion of anything is. I'm going to say fractional excretion of X. In this case, X is sodium, but X can be anything. Fractional excretion of urea is another common measurement, and fractional excretion of bicarbonate is also a common calculation. So let's just do fractional excretion of any solute, which is X. It's going to be equal to the amount excreted in the urine and that's going to be divided by the amount that's filtered. And all we have to do is determine these two numbers in order to get the fractional excretion. So let's move down a little bit and start work on the fractional excretion of sodium. Well, we've run out of room, so let's go back up and let's clear this screen. Alright, so we've got the fractional excretion of sodium, or X in this example, is what's excreted over what's filtered. This is the most simplest way of understanding the fractional excretion of anything. Let's work on the excreted part first, so we'll come down here. Since we're talking about sodium, we know how much sodium is excreted in the urine because we're able to measure the urine concentration of sodium, and we know the amount of urine that's made. So when you multiply these two together, you're going to get the milliequivalents of sodium that are lost in the urine. And the good news is that this is a measurable term, and this is a measurable term, so you know the value of both of these variables. So you've actually got the numerator all figured out, and we're talking about sodium here, so I've written sodium, but this could be anything: bicarbonate, urea, even a drug. So here you've got the amount of sodium that's excreted, and now we have to figure out the amount that's filtered. Well, the amount that's filtered Let me draw this out here for you. It's pretty straightforward, but let's just do this anyway. Here is your glomerulus, and here is your efferent arteriole. Here's your afferent arteriole. And we're not looking so much for the amount of sodium that comes through here, but we want to know the amount of sodium that goes this way. And to figure that, that's what's filtered. That's the serum sodium concentration. I'm sorry. Let's change that and keep all the nomenclature and symbols consistent. And the amount of volume that gets filtered through the glomerulus. Well, that's the glomerular filtration rate. So you've got the concentration of serum sodium times the glomerular filtration rate. This is milliequivalents per liter. This is volume or liters per unit time. When you multiply the two together, you're going to get milliequivalents of sodium. Up here you've got urine volume. It's actually urine volume over time, and usually the time here is 24 hours. So you'd know how much urine volume you have over a 24-hour period. For glomerular filtration rate, you'd know how much volume is being filtered per any unit time, minutes, hours, or even a day. So you just keep the units of time the same, and you'll be fine. Now you can measure serum sodium, but you cannot measure the GFR. At least you can't measure it very easily. And you've got to have these four variables before you can calculate the fraction excretion of any solute. So let's figure out how to get the GFR. And the GFR is a little bit easy to figure out because we know we make an assumption that the GFR is approximately the same as the creatinine clearance. I write creatinine clearance this way. You may see other people write creatinine clearance as this. But they're pretty similar to each other. So all we have to do is figure out the creatinine clearance. So the creatinine clearance, as you may remember, is simply the urine creatinine times the urine volume divided by the serum creatinine. So we're just going to plug in this term into the GFR because we can measure urine creatinine, we know this quantity, and we can measure this quantity. So we have a parameter that's measured, 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 and measured. So we should be able to solve for the fractional excretion of sodium. So let's go on to the next and the last page. So we get fractional excretion, in this case it's sodium, equals what's excreted, which is the urine sodium, times the urine volume. And remember, we're doing urine volume over a particular amount of time. Let me go here for a minute and get to the eraser. Let's see if I can get this cleaned up. Alright. And what's excreted is the numerator. What's filtered is your denominator. And that is serum sodium and your creatinine clearance. But we know what the creatinine clearance is, so let's just rewrite this. Now we've got urine volume up here and urine volume down here, so these cancel each other out. And we'll just rearrange this formula. And there we go. You've got your nice and easy formula to remember, of the urine of the fractional excretion of sodium. And now you know how we derived it. And so if you ever get stuck on an exam or on the wards and don't know how to figure this out and don't have a calculator handy or one of those pocket books, you can work through this. It takes about 2 or 3 minutes and you'll get the right answer almost every time. So thank you for viewing this tutorial, and we'll see you later.